Good morning, students. Hope you are doing well. In today's lecture, we will discuss about fire and electric hazards in the lab as well as like in other workplaces. So in fire hazard, we will cover about like what types of fires, how the fire is ignited and in the lab, and what type of fire extinguishers or like fire suppressors are being used depending on the type of the fire. And there are many other like small subtopics like what we have to do, like if there is a fire in the lab, what is the response of the students or being a worker if there is a fire hazard. And similarly, we will talk about the electric hazards and like how the electric hazards we can stop them, how like the electric the main causes of electric hazards, and we will also discuss about the effect of different electric, the voltage or the currents on the body of the human, so that you will be like more careful about electric hazards. So let's start with the fire hazard. So what is basically the fire hazards? So any material, like for example, any substance or action that increase the chances of accidental fire. Okay, because of course the fire is very helpful. So but if we are going to ignite the fire like in a planned manner, for example, if we are doing experiment in the lab, like in the laminar hood or safety or biosafety cabinets, we need the fire. Okay, so that is planned, but this there is if there is a accidental or unplanned fire, so that is become like a fire hazard. So what are the safeties that we need to make sure like we are safe? So these are the set of practices that intended to reduce the destruction of fire that are caused by the fire. So these are the practices or like the procedures that we follow to reduce or destruct the causes that caused by fire, or like the precautions that are taken to prevent or reduce the chances of a fire that ultimately, of course, that maybe can cause like the death or injury or like any damage to the body of the person or the workers. So this is kind of like a fire safety and the fire hazards. So how does a fire work? So this is really very important. So if we understand how does a fire work, then ultimately once we are going to control it or we can want to demolish it, so then we can stop it. So it's really very important to understand or remember this rule. So fire work depend on like three elements. So you can see here, this is the triangle showing three aspects or the three elements: oxygen, fuel, and then of course this heat. If these three elements come together, then there is a fire. So the fire ignition start. So if one of the aspect is missing, then there is no fire. So if there is no oxygen, whether there is a lot of fuel or the heat is temperature is very high, so there will be no fire. And similarly, the rest of the elements, if all these three elements come together, then there is a fire. What are the common fire hazards normally, like the similarly like in the lab as well as in other workplaces or the domestic the life. So this is very common practice or the common the things that we see here. You can see the overloaded electrical system. You can see here in this wall there is a socket and it is bearing a lot of or so many plug-in different wire cables. So because what happened, nobody like a bother about like the voltage. So how much like voltage is coming from the back, from this cable, and how many like equipments are putting or we are pushing or we are going to run from this track, right? And then of course the temperature will be high and it can cause the fire. So this overloading can cause like electric, the very common fire like into the buildings or in the labs. So sometime the materials those produce toxic once heated, so they can also catch fire. And similarly, fuel store areas. So these are the always very sensitive areas, and in the lab, sometimes we have store or some other cabinets. So we are store some kind of fuels. So if there is like a high oxygen concentration or insufficient protection, so it can also cause the fire. Here you can see the cooling system, and sometime of course the blockage of this cooling event, that's cooling is coming like outside, right? If there is blockage happen, and then of course then it can also catch fire. So these are the very common the fire hazard that can be happening to the lab or like any office or any workplace. Uh, Especially for the lab, you can see this is a small equipment very commonly used. So we call it like a hot plate, or like this small equipment is used to boil some the chemicals, or like to heat up some chemicals. Okay, because it has dual functions, so it can increase the temperature as well as it can stir the magnets. So if we insert the magnet inside this flask, so it will also stir, it will shake like, and it will mix the the salt into the water or any solution you are making. So this is very nice machine that we are using in the lab. And similarly, on the same time, it can cause a lot of fire options, like opportunities. So the misuse of this plate, this is, we call it a hot plate. The misuse of these plates can cause like a fire, because sometime if once you finish, and you did not switch off the temperature, and if any paper or something comes like on the top on the of the plate, and it can catch fire very easily. So also combustibles, whether this is anything that is combustible near or around the heavy equipment, not come, because it's a high energy and there is a high temperature, it can also cause a fire. Similarly, flammables, whether this is a liquid or any like a flammable material, not like left on a hot water heater. So because this is another equipment that is also commonly used in the lab. Okay, so of course then it will also be cause one of the source to catch the fire. So as I mentioned previously, normally we use a natural gas in the biosafety cabinets as well as in laminar hoods, and we need to of course ignite the fire. We use the match or the flame stick. So sometime once we uh, just switch on the fire, and then of course we just dispose of this match lights. So this is not completely the switch off, and it can cause fire. Whether this is you put into the bin or somewhere else, it can catch sometimes the fire. So this is very common practice we see, like mostly like the workers, they can throw like unswitch off you know this match into the dustbin, and there are papers and some other stuff, it can catch fire. So now how we can stop the, if there is a fire, how we can stop, like so we will talk about the fire extinguishers. So this is the equipment that is commonly used to stop the fire or to suppress the fire. So fire extinguisher or fire suppressor. So both terminologies are used for the same purpose. So it is this machine or this equipment contain the we call it a fire protection device that is used to extinguish or control small fires, so often in emergency situations. So they contain certain chemicals, and once we use these small devices, so it will stop the fire. So how it actually work, as if you remember in the previous slides, there is a triangle how to set up the fire or how to ignite the fire. So this is a triangle, so there are three elements, right? So you remember what are those three elements? Oxygen, fuel, and heat, right? So the function of this fire suppressor is to remove whether this one or whether this one or whether this one. So the function of this fire extinguisher is to remove one of the element, and if we remove one of the elements, then it will finish the fire, it will stop the fire. So the basic function or the basic formula to make this fire extinguisher is it will remove one of the element that cause the fire extinguisher, that set up the fire. Okay, So there are five most common, the fire extinguishers are being used. So these, according to the nature of the material, so they are used and they are produced. For example, one is all-purpose water, carbon dioxide source, multi-purpose dry chemical, dry powder, and foam extinguishers. So this each extinguisher or suppressor has a specific use. As I mentioned, so their use will be according to the nature of the fire. So in the coming slides, we will cover about like there are different classes of fire, and according to the nature or the class of the fire, so we will select any of these fire extinguishers according to the nature of the fire. And similarly, you see like it has a specific color. For example, nowadays this is very commonly used, red color fire extinguisher or suppressor. So before it was like there are different colors, red for water, cream for foam, and blue for dry, and black for carbon dioxide. So this is the old system. So this system was like according to the material that is inside the extinguisher, it will also give us the colors. If you see like there is a fire extinguisher having like blue color, so it means dry powder. But nowadays, according you see like all fire extinguishers have like a same color like the red one. Okay, but this was the old color scheme, but it was very good. Like also like if someone I remember or recognize like the color with the material that is inside. So let's talk about the classes of fire. There are different types of class fires. So let's discuss about class A fire. It involves common combustibles such as wood, paper, cloth, rubber, like these materials. So the most of the the things or the common combustibles, those are fall under this class A fire. They produce like a kind of ash, all these rubber or like wood or cloth. So once they burns, they also produce kind of ash, right? So the foam extinguisher can be used to stop, but not be used when electrical hazard is present. So normally foam, the foam extinguisher we use to stop class A fire. But if there is chances of electric hazard, I mean like there are wires or the, for example, okay, so if there is a fire, the hazard due to electric or electric socket or electric, the wires, so then of course you will not use this foam extinguishers. And of course, dry chemical, the can also be used. They contain like a halotron, water, and foam. So they ABC dry chemical. So this is a multi-purpose fire extinguishers, and it contains the halotron, water, and foam. So they can also be used. Class B fire, so the flammable liquids, solvents, and others oil-based product that make or ignite the fire. So this is called fire class class B fire, and the extinguisher that we use to suppress this fire is dry chemicals or carbon dioxide. Dry chemicals or carbon dioxide. So carbon dioxide suppressors are be careful because carbon dioxide is volatile. Okay, because it is volatile, and there is a however no post fire security, and fire can possibly reignite if the source of ignition has not been removed the 100%. So you got my point, because carbon dioxide is volatile, and if the fire is not suppressed like 100%, and even there is a small of the flame or like even a spark, they can also restart the fire. So this is very important due to the carbon dioxide. Class C fire involves energized electrical equipment such as wiring equipment or like motor, computers, electrical panels, or etc. So those type of fires fall under a Class C fires. And of course, they also a source of electric shocks. So it will be we use like dry chemicals or carbon dioxide. So not like the foam or etc. Okay, because there are chances of electric shock. Okay, so the extinguisher that we use, it should be like dry chemicals or carbon dioxide. And Okay, so but conductive agents like water not be used. So it means like any fire extinguisher that contain kind of liquid or like a water stuff we will not use because this is a conductor, so it will can cause like a electric shock. Then class D fire combustible such as magnesium, sodium, lithium, potassium. So the source of these combustible sources fall under class D fire, and the suppression type that the agent we use for this kind of fire are dry powders. Okay, so depending on the combustible, so we will use the suppressors accordingly. So what happen if somebody catch fire? For example, the person, if somebody catch the fire, what happen? So should we use the fire extinguisher or suppressor that we discussed before, like 4 or 5 different types of fire extinguishers? Can we use? No. This is very important to understand. No, we should not use fire extinguisher on the people or the person. Okay. So if somebody catch fire, so this is the the normal or the like the major rule. So the person can lay down on the ground and then put the hands on the face, and then of course the other, the helping or the supporting people, they can wrap this person with the blanket, like the sheet that we have, like a fire protecting the blanket or the sheets. So just wrap the body and stop the fire. Or okay, so, but this is really important not to use the fire extinguishers on a person. So, common practices fire prevention, working with the different the equipments in the lab. So you can see here. So this is a very small the equipment that is commonly used in the lab. So because we need sometime whenever we need like extra heat or we want to decontaminate some stuff, so this small equipment is actually equipped with the biosafety cabinets as well as in the laminar flow. So this lighting flame can cause sometime fires because the flame this because sometime if the release of the oxygen is not like in a high concentration, so even the this flame is not visualized. Okay, so this is very important. And if you are working then of course, and you have to go somewhere like in the office, or you want to discuss with doctor, or you want to go some maybe on the small store or etc 5 minutes away from the lab, so then of course you need to be alert, like don't like leave this flame unattended. Okay, and secondly, because this equipment is also connected with this gas valve. Okay, and of course always not only like the stop the flame, but also need to stop this gas from here. Otherwise of course the leakage of gas will continue until although there is no like a flame over here. Okay, so this the heat reaction with the flame, of course it's very dangerous. Turn off the natural gas whenever you are not working or if you are away from the experiments. So always turn off, of course, and also turn off the flame. So you have to do like two things. Okay, so this is really very important to avoid the fire. So there are also the chances of the sparks and ignitions. As I mentioned, you can see here this is the small equipment that we are using uh, for heat for certain purposes, but at the same time we have different flammables or combustible materials or the liquids, and if they are very close to each other they can catch fire. And here you can see like the hot plate that I mentioned in the previous slides. So sometime of course, because it is equipped with a temperature as well as spinning the magnets. So the high temperature or the continuous temperature, if somebody's forget to switch off, so of course it can catch fire, it or one of the source of the fire, whether this is a metal to metal or metal to concrete, or it's like even either chemical or can touch to this one, or the paper can touch, and anything. So of course this is really important. We need to use brass or the plastic tools when working with the flammable stuffs or the liquids. So what is the reaction of students in case there is a fire? So this is the responsibility of every student. Notify your friends, like in the lab fellows. Sometime might be some students are working on the lab biosafety cabinets, or maybe someone is busy in the store, right? So, and somebody is like in the labs into different sections. So always mention or like notify like everyone that there is a fire. Sometime maybe they cannot observe, like they are so busy, maybe there is a heavy sounds if they are using some equipments in other small rooms, etc. Okay, if possible, shut down all or any reaction that is in progress, because for example, if you are quickly going outside and might be like the this emergency may be prolonged and you cannot come back. Okay, so this is really important if possible, right? So for example, if the emergency is very high, of course, then your life is more important, right? But better like to shut down your reactions if there is a like the normal emergency, or quickly you can stop the reactions, or if you are working on the machines, just to switch off the machine quickly. So proceed to the nearest exit and evacuate to the building and go to the evacuated area or the particular area, so the assembly point, and then of course wait there until you heard or like get the instruction to come back. So always stay into that designated areas, of course, and this is very important to remain calm, and of course never enter building until instructed, or enter like a RMO office, or like the administration people, they allow like now like there is no uh, any chance of danger, so then you can coming back. Okay, in general, so you hear alarm, so don't assume it is a drilling or like because your life depend on it. So this is very normal practice. So whenever there is alarm, so consider it is emergency, a fire alarm. Okay, don't consider it is a drilling or like it's a false alarm kind of stuff. Okay, so this is I think this is a normal or moral duty of everyone. If there is alarm, so just to follow that alarm. In this slide you can understand like very important information about never fight a fire. Never fight a fire if any of the following apply. Okay, so this is really important to remember. If you don't have proper extinguisher equipment, then of course you never fight with the fire, not trying to stop the fire if you don't have proper this equipment. Secondly, fire, if fire is spreading beyond its point of origin. Okay, so if for example fire is spreading into different directions, so it means the frequency of the fire is very high. Okay, so then of course you will not fight, not try to stop that fire. And the third one, if your inner instinct, so in your like instincts tell you that get out, so it means like the danger is high. If your instincts tell you the danger is very high, so then of course you should follow your instincts, right? Then run away or not like a fight with the fire. So these three steps are rules are very important. If you do not have any of if you found any like any of these three the rules, then of course you should follow or never fight with the fire if any of these is happen. So there are certain fire rules, for example, equipment using portable electrical heated elements are only allowed like in the SQU buildings. Okay, so there are, this is rule, so we cannot change, we cannot move like any equipment. And similarly, the materials not stored with the zero point 0.5 meter of an extinguisher or fire hose. Okay, so this is very important because in an emergency, so the fire brigade or like the other the machinery, they might be use this one. For example, this is the water pipe and this is also water pipe. Okay, the fire hose. Okay, so this is a rule. Okay, so we have to follow, don't block this one. Even sometime you can see like there are yellow or like red lines close to the parking, and it means like there, and you can see this sign. So of course you do not park your car around or close to this one regarding this distance, and they mention like the lines and it's not allowed of course like the to make any physical changes to the lab or the building of the SQU. Definitely this is I think understood. Fire risk assessment, of course, we cannot ignore this one. The fire risk assessment is the process involving the systematic evaluation of the factors that determine the hazard from fire, possibility that there will be a fire, and the consequences of one were to occur. So this is the responsibility of RMO. Okay, so this is a RMO in detail we discussed in the first and second lecture. So RMO officer is responsible to get the assessment about the fire hazards. So what RMO do actually? It identify potential fire hazards in the workplace, like for example the RMO officers. So they usually visit the labs like off and on, and they identify like the potential fire hazards. And secondly, they decide who, like employee, visitor. So employee mean here also like students, all staff, etc. Okay, might be in danger or in at the event of fire or in the workplace. So they evaluate the risk. So these steps, they follow these steps. So this is the assessment procedures. So they evaluate the risk arising from the hazard and decide whether need any improvement or not. Okay, and secondly, of course, they record all findings and details and then make like action. So whether you took as a result of that particular incidents or like a particular data. And finally, they keep assessment under review. Okay, so for so each year, especially each year, but off and on, they also observe like each labs and other the workplaces, offices, or like classrooms as well. Okay, so the RMO, the risk management officer. Okay, what is RMO? RMO, risk management office of SQU. So they keep these risk assessment using these five steps, and then of course um, we sometimes don't know like, but they are doing like their job, and they install like the proper insulation or like other if there is a chance of any the fire. Let's talk about the electrical hazard. So electrical hazard is a dangerous condition where a worker can or does make electric contact with energized equipment or a conductor. Of course, get the electric shock. So electricity is a type of energy fueled by transfer of electrons from positive and negative points within a conductor. And of course, everyone is working in the lab, so we have to use electric equipment. So we should like really understand about these electric hazards. So in this slide, you can see two materials. They are very important to discuss, like conductor and insulators. So in conductor is a material, you can see here there is a conductor and there insulator, and here is a conductor. So conductor is an object or type of material that allow the flow of electrons. So the electric current actually pass from this conductor. The wires, they have like metallic stuff. Okay, so they have different gold, copper, silver, aluminum stuff. And this is the insulator. So insulator is a material uh, that does not allow to pass heat, electricity, light, or sound through this material. So this insulate is provide insulation. Okay, and it is made up of like wood, rubber, gas. So for example, if you can see here is a conductor, and even if you touch with the wood, you can just hold the wooden, dry wooden, and then you touch it, so it will not pass the electric current, because this is an insulator. And here you can see, so all like the different wires, so they are protected with the insulators. So and this is the conductor, but these wires are protected with the insulator, so as it will secure us, like don't make any electric. What is a shock or electric shock? A sudden discharge of electricity through a part of the body. So whenever somebody touch the conductor, and of course then the electricity pass through the body, so it call called the shock. And what about the severity of the shock? It depends on these the voltage of the current, voltage and current, and then of course what kind of resistance and how much resistance it has, and the path through the body. Okay, so this is also of course depend on like the path. For example, this is going from hand to here, right? And if we touch from here hand and going like in the ground, like through the whole body. Okay, it depends, and of course the here is resistance is different, and from the whole body is resistant. So path of the body, of course, it is also very important. And the last one, duration of shock. Of course, it will decide the number of electrons, how many goes like the electricity, how much electricity voltage current pass through the body. So all these things, depends on the severity of the shock. In this slide, you can understand better about the electric shock and its effects on the human body. So with the comparison of current, so here is the effect, and here you can see the current, a milliampere current, right? So for example, if there is a 0.5 to 3 milliampere current, you can see it can cause the slight tingling sensation to the human body. So kind of like the kind of itching, kind of a tingling sensation, slight. It will not like dangerous or harmful. So if this current is increases from 3 to 10 milliampere, small shock, muscle construction, and little pain can also cause. This the current is high, 10 to 40, so muscle contact to freeze. So then of course the muscles contraction is higher and it can freeze the body. And if it goes 40 to 75, so then respiratory muscles become paralyzed. So of course this starts like, because it's a high current, and it can cause like more dangerous aspects of the body. And similarly, if 100 to 200 milliampere, it can also burn your body, like you can see like wounds visible. Okay, it can also burn the skin or the body. And if it's between 200 to 500, so then clamps are tight, become like a hard hearth clamps tighter. So then of course then the clamps of the in the different body parts can also become. If this is the highest one of 1500 plus, then tissue and organs start to burn, leading to death. So in this way, like different organs, they can also start like burning and leading to death. Of course, then of course all different effects are. So regarding the exam point of view, so overall, would not suggest like to memorize everything, but of course you can divide into three scales, for example, like the minimum and the medium effect, and then of course the high factor. So like these, so of course, so that this information is important, but couple of the questions you can also ask. So there is a question, why do people freeze when there is a shock? The normally, like for example, if there is a we touch to the hard surface and any other like uneven things, and because we have a strong nervous system, and automatically we detach our body parts, like even we are not like thinking about to remove our hand, but it's automatically because due to the nervous system. But in this electricity, you can see our body freeze. So even if somebody touch to the electric current, so it will not remove. So because your body is freeze, because the electric stimulation causes the muscle to contract. Okay, so it will you cannot remove your body parts or your like a hand. So this freezing effects makes the person unable to pull or remove your finger or hand from the socket, or from the source of electric current. And what should we do if somebody freezes to a live electric current? For example, here you can see if there is a the live or energized wire, and somebody is freeze, and still its body is touched with the live energized electric current. Of course, so as I mentioned in the previous slide, so we need insulator. So as I mentioned, there are certain plastic, wooden, so these are the insulators. So insulators are those equipments in which the electric current is not passed, the electricity cannot pass. So those materials are called insulators. Here you can see this guy is using a wooden stick. So take the wooden stick and remove the energized or the source of electricity first, and then of course detach from the body of the person who is freezing with this energized electric circuit or electric wire. Most of the electric accident happens due to the following three factors. So for example, unsafe equipment installation, and unsafe environment as well as unsafe working practices. So all these the cause electric the hazards. So because if there is a unsafe equipment installation or unsafe environment or the working practices are not right, of course, then of course you are causing or inviting like the electric hazards. So what is the best way to protect yourself against electric hazards? Of course, proper PPE is very important, and then insulation and gardening and grounding electrical protective devices. Nowadays, like these are very commonly used and safe work practices. So the electric protective devices. So these are the devices if somebody got like a electric shock a little small, so they automatically, even without a shock, so they automatically shut down the electricity, so they stop the electricity passing. And grounding actually nowadays, like in advanced or the latest or the modern equipments, automatically there are wires, so those are free and they can touch to the ground, because before it was like each equipment has to be put like one wire to into the ground so they can make the current leading to the ground, not to the other areas. So these are the PPs. Very commonly PPs used for electric current protection. You can see special helmets, special gloves, and everything. They are insulated. You see they are very insulated. These small equipments. So these are the all made up of like rubber stuffs, and because they have insulated with the different the very nice material, plastic or like rubber, and of course they have rubber, etc. So these are the kind of special PP for electric hazards. What protection does insulation provide? Insulation, as I mentioned, all wires, so they have like the protection. They are insulated with certain the insulators. So it stop or reduce the flow of electric current, and also will help to prevent shock, fires, and short circuit, of course, because if they are well the protected, and of course it's not like there is no naked conductor even in a, so next slide, I think I will slide in, and on next slide I will show you certain examples of these insulator and the conductor the damage. So circuit protection devices, so you can see these are the small circuit protection devices, and they stop or limit the flow of current automatically. So when there is any incidents happen, so automatically they switch off the electric current. So normally in each the settings in the normal, in each lab or in each home, or I think everywhere these are settled, and if there is a somebody touch to the electric current, so automatically the electricity switch off through the whole areas. So these are the kind of examples.